little bit weird. This one says to circle. Oh, you guys are fine. Never mind. I get it. The list that I'm getting back from everybody, shows for this one some kids. Anyway, never mind. Mrs. Pratt's knows it, and we're good. They had some of you guys signed up for CalcAB and BC. I'm like, you realize they're in AB, right? And they're like, yeah, they're just circling, and then the office doesn't know which one they're in. And never mind. Just make sure. I mean, it would be nice if you guys haven't done it yet, circle AB instead of circling AB and BC. But don't worry, Mrs. Pratt's and I will figure it out. But get this turned in. I do have extra copies, and so I'm going to put some on the desk right here on the way out. Or if you guys want to come over and grab one or have someone grab you one if you still need to turn them in. But we are missing quite a few of our AB kids. Speaking of AP exams, hold on. Speaking of AP exams, what needs to happen before the AP exam? The mock AP, aka our final exam. My calendar's missing. Hold on. Sorry, guys. Okay, according to our syllabus, when is the mock exam? Well, that's fun. April 6th. However, there's a dilemma. I need to pull up really quickly for you guys the calendar, which is brutal, even though you guys can't tell necessarily. I can tell. It's just disgusting. Anyway, the calendar, if I can make it any bigger, I will try to. This is the school calendar. This is when we were supposed to be having our AP test. I put in a request back in August. And Mrs. Leon chose, based on that, to do the next weekend for her AP Chem kids. When I was looking at the calendar really quickly, I was like, wait a minute, why is hers on there and not mine? Long story short, one reason or another, mine didn't get put on, and so I went checking to be like, okay, so is everything still good? Because I got the approval. Long story short, the AP Calculus classes, there's too many of you. And all the spaces on campus that are big enough to house us are in use. The library's in use, the gym is in use. I don't know why the gym's in use, but we don't really get to see all the athletic stuff, so you guys can see why I don't always know when athletic stuff is happening, because it's not on this calendar. But anyway, long story short, the gym's in use, the library's in use, and they're like, basically, we don't have a spot for you. And I was like, great. So instead, they told us that we needed to figure something out as far as between AP Chem and AP Calc. So Mrs. Leon graciously offered to have her kids take their final 1 week early, and we have an extra week to practice. But what's the dilemma with this Saturday, everybody? Yeah. So here's what we need to talk about, and I'm not going to make a decision today. The office has, because I kind of reached out to them, and I'm like, oh, it's the first Saturday of Easter break. My kids weren't necessarily planning on it, but obviously you guys weren't planning on April 6th either, because no one knew when the actual mock AP was. So, I mean, I don't know if it's really that much different. However, I need you guys to talk to parents and figure out exactly what's going on as far as, like, Friday after school, you're driving to LAX and flying out of here, or something else. There is an ACT off campus also as well, but I have asked if we could possibly do it Friday right after school instead, and they said yes. So we have the option between Friday after school for like 4 hours, which is what anyone who misses the actual day of the mock AP, usually there's a track meet on the day of that usually pulls kids away. I've had kids be in different states visiting colleges on the day of. I've had kids, something happened with their ride the morning of, and they had absolutely no way of getting here. Actually, no, that kid came 2 hours late and still finished the AP and got a 5. But anyway, that was a very special circumstance. Doesn't usually happen. So anyway, I always offer one makeup day anyway. So if there's only 1 or 2 of you that are going to be out of town both Friday and Saturday, because we have to choose one, I'll pretty much figure out from voting which of you could be available this day and or that day. Like you could vote for both and be like, hey, I could do either one. Whichever one has the most hands, the most people we're going to do. So that way we inconvenience the least of you. The makeup day, I would love to have it before. However, if someone misses the day of, that means I have to find another 4-hour time slot to have absolutely no one in my room after school to do a mock AP, and that's just not possible for me. So you guys know what my room is after school sometimes. And 4 hours after school, it's hard to just chunk out. So instead of having one before, there will be a makeup one the Wednesday after we get back from spring break. Because Wednesdays are usually the best day as far as practices. You can usually get out I mean, it's not like a usual. If you miss the mock AP, you have to come on the makeup day. So you guys are thinking, could I make Friday or Saturday? I know there are different international trips, the France trip, stuff like that. So that's why I'm having you guys start thinking about it now. It's going to be Friday night, right after school, like around 3:15. You guys won't get the yummy breakfast food that I usually make on Saturday morning, but we'll do like Costco pizza, something, 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 and get you guys spoiled in another way on Friday night. But anyway, Friday night after school for 4 hours, that'd be about 3:15 to about 7:15, 7:30. We should be able to be done by 7:15. And then you're just done, spring break. Whew, you're done, spring break. Or Saturday morning, 8 to noon. So you guys just need to be thinking about which one you could make, and maybe if you make both. And then if you're like, there's no way, okay, then you need to put in your calendar Wednesday after school from basically the same time, 3:15 to 7. Because I always have a few that can't make it for whatever reason, and that's the makeup time. Okay, you guys realize this is your final exam, true? Okay, talk to me individually if you're like, I can't do any of them, and you have really good reasons. We have to work out something because I can't just give 4 random hours of my day. Michael.
Okay, so you probably said this at some point.
Oh, it's okay.
What if we just like don't do good on the mock this year? We're gonna get like a bad final grade. That would suck.
Oh, I see what you're saying. I guess I haven't really announced it, at least not this semester. I think I did the syllabus day, but it's a long time ago. You guys know that the AP scores are 1 through 5, right? Okay. I'm giving you a 1 through 5 based on an actual AP scoring guideline. It's not perfect, but in the sense of I'm kind of using, I always use like a blend of multiple years, etc. Based on ones that are like password protected, teachers lose their licenses if they're posted online, that sort of thing. Or their AP teacher status. So I will be able to give you a 1 through 5, and not just a 1 through 5, but what your raw score was and where it fell within the ranges of the 1 through 5. So it's not just like a 1 through 5, but it's like a low, middle, high, and here's exactly where you placed in the range where they give the 1s through 5s. The reason why I'm explaining that is because I kind of scale all of that down to, as long as you tried the AP. I've never had this happen yet, but I've had some people threaten to do it, and so I've had to make this. As long as you try on the AP, then I will do this curving for you. Otherwise, I'll give you your strict percentage, which could be pretty bad, because a 5 is usually a 65% or above as far as getting correct on the AP itself. If you get in the 1 range and you work hard to get that 1, not as in like I know exactly how much you studied and you write me a report about how hard you worked, but as far as like I see you attempting the exam the whole way through, then you're in the 60s range, 60 to 69, and I scale whatever that range was as far as the scores in those 10 percentage points. So 1 gets you a 60 to a 69, and you can't score lower than a 60 if you try hard. A 2 gets you in the 70 to 79, a 3 gets you in the 80 to the 89, a 4 gets you in the 90 to a 99, because if you're getting a 4 in the AP Calculus exam, I am so proud of you, and then a 5 gets you 100, automatic. Does that make sense? So I'm curving it like crazy, because the 65% becomes 100. Is that cool? Okay. And so some of you are like, the lowest I can get is a 60 if I try hard? Now, that's supposed to motivate you in the sense of like, what? Go, buddy. I'm going to get a good score on this test. But you don't want to get a 60. Like, it's your final exam. You want to get a 70, 80, 90, 100. But anyway, Michael, thanks for asking that question. All right, cool kids. Yeah, it was a great question. Okay, so you know what you're doing as far as your calendar, true? All right, figuring out whether you need to bank on that makeup on the 24th. Or is that the Wednesday? Yeah, whether you need to bank on that makeup on the 24th or whether, which will just be in my room, or whether you can only do one or both of these when we take the vote, probably tomorrow or Thursday. I talked to Period 6 yesterday. I just need to talk to BC today. The reason I didn't talk about it earlier was because we were getting ready for a test, and I didn't want you guys distracted. But now we have to talk about it. All right, cool kids. Thank you for that. Let's go ahead really quickly. Your integration is net change packets. You have it in front of you. You have your notes ready to go pretty quickly, but first, here we go. Is there anything, a burning question on the evens, either a discrepancy in your groups or I didn't know what to do? Nick?
Wait, sorry, I had a question about the
Oh, sorry, go ahead.
So, we're taking a live AP in literally like a month, then how many more chapters do we have?
1.5. And it's a little bit more than a month, especially since we just got an extra week to study. So we have a month and a half-ish, week and a half, a month and a half-ish, and a chapter and a half. So we're going to have a few weeks to, at least 2, maybe 3 weeks to study to the mock AP. And then we get another, including spring break, another like 3 weeks after. Yeah. And the nice thing is with us taking it right before spring break, I haven't done that ever, I don't think. I'll be able to bust out the grading, so it's kind of like you give me the AP or the mock AP. You go and just enjoy life over spring break. Yes, I'll give you another mock exam and I'll give you forever quoting, but and then you come back and I'll be like, here's your exam. Usually you have to wait a week or 2 before you get it back, but well, I'll be in Baja. Maybe I'll be taking FRQs. He made it. Can I have your notepad? Thanks. Evens. Sorry, burning question. AJ. 10C. Any other burning questions on the evens? Thomas. 12D. Did you guys realize, like, theoretically, A and Bs are usually pretty straightforward? Not that they're always easy, but they're fairly straightforward, and then Cs and Ds get a little bit weirder, rougher around the edges. That's common. Okay, 10. We talked about yesterday, this is a graph that is not geometric, right, guys? Okay, not geometric, so we can't actually find the exact areas, but they did give us a what? An equation that you could plug into your calculator, and you could find exact areas. Wait, what does the area in this scenario stand for? The area under this curve, what does it stand for in this situation? Number of cars that are turning left over a certain time interval, right? So at one point, you guys needed to find from 0 to 18, hopefully just a simple plug-in chug of a definite integral. But that was how many cars turn left over all 18 hours, right? What's different in letter C? It's bringing in this new situation of, hey, depending on the busyness of the intersection, that has a special formula that's someone somewhere higher up than whatever your pay is if you're thinking about this question. Some formula that says, okay, yes, it's busy enough for a signal, or no, it's not busy enough for a signal. But does it need to be this busy, that formula, for the entire 18 hours? No, what does it say? If there is any 2-hour time interval. So looking at this graph, here's my question. If this little traffic engineer dude had to actually go out and figure out exactly how many cars were turning left, etc., or actually go consider, I mean, some of you guys have seen, at least I've seen up in Santa Clarita, different people who are camped out at different intersections and they're measuring this, that, and the other. It's not always necessarily how busy it is, but sometimes it's actually, oh my goodness, why is the word escaping me? You guys know the guys with the red vests and then they have like the pole things and they're measuring stuff. What are they doing? Wow, the name just totally left me. But anyway, Caltrans workers, etc., that are out there measuring stuff. Would the traffic engineer literally have to sit out here for 18 hours? Be smart. Your time is important. When would you sit out if you're trying to figure out how busy this intersection gets? And all you need is one time where it's busy enough in order to put in a signal. Okay, so where is it the busiest in this interval? 14-ish. Good, right? It's the busiest around, so just go out the busiest time of day. Your time's important. Now hold on, 2-hour time interval. If you have to actually take measurements, if 14-ish is the highest, which we could find it exactly, but we're just kind of estimating. If 14-ish is the highest, okay, well, what do you guys think, what time interval would you go out there? 14 to 16? 12 to 14 or 13 to 15? That's what I would do. So my advice for letter C down here is A, you have to translate that little formula, but there is a little formula, right? Didn't it say something about the product? Isn't that multiplication? Times the total number of cars turning left. We just said that's the definite integral from A to B, and we just said, hey, maybe you should look at, to save your time, 13 to 15, because that's when it's busiest. And the total number of oncoming, whoa, cars traveling straight. What do we know about that? Yeah, didn't they tell us that clue right down here? 500 oncoming cars travel straight through the intersection in every 2-hour time interval. Is that practical? No, they're just trying to give us the information in a nice, short, sweet version so we don't get too confused. And then what has to be true for them to put in a signal? Yeah, so we have our 500 times. We're going to check our 13 to 15 of our, what is it, L of t dt, right? And we're going to see, is this greater than 200,000? If it is, I think we're pretty good, and yeah, we should put, well, not if it is, not probably. If it is greater than, yeah, it needs a signal because it gets busy enough that it meets their formula. If the busiest time of day is less than, okay, forget it. We did the best we could, and nope, it doesn't need a signal. Does that kind of make sense? But then I also heard, Thomas, you say, let's go look at number 12. It was the table one, right? What was the situation? Oh, it's the pot of tea and biscuits. It's one of my favorite. Although the kids that year didn't like it so much. I don't know why. Literally, just put biscuits in a problem and people freak out. Anyway. Letter D, yeah? Okay. It says something about cooler than the tea. So a quick reminder, at the very beginning of the problem, we did talk about tea. Or the problem talked about tea, right? As a pot of tea cools, the temperature of the tea is modeled by the differentiable. They do not give us an equation. That's all right. They give us a table. The big idea down here, you guys see the big idea, right? We want to know how hot or how cool, whatever, the temperature of the biscuits and the temperature of the tea at 10, true? Have you guys figured out somewhere earlier in the problem how to find the temperature of the tea at 10? Yeah, you have to use the table. Can't we just pull it straight out of the table? Because the table gives us degrees Celsius, right? So the T at 10, isn't that just H of 10, which is equal to 43 degrees Celsius? Okay, so that's easy. What do we have to work on? The biscuits. All right, so I think the biscuits only showed up in letter D, true? Okay, so for the rest of this problem, we're focused on exactly what they gave us. Ooh, did they give us an initial temperature? I think that's a clue. Am I maybe needing to find a B of B given a B of A? And all I need to do is figure out the change in over those 10, what was it, hours? No, that'd be ridiculous. 10 minutes? 10 minutes, how everything changed. Hey guys, what formula is this? Integration as net change. Booyah! We can figure out how much the biscuits have cooled off. And then we can add that to the initial. Now, hold on. Cooled off, shouldn't that be a negative change, right? But do we have to make it negative, or are they already realizing that the temperature is decreasing? Yeah, the rate's decreasing, or I should say the rate is negative, so the temperature is decreasing. So when you find this should be a negative number. The biscuits better have cooled, or else you're in some trouble. But then all you have to do is figure out who's this guy and how does he compare to that guy, and then booyah, you're done. Dun, 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 dun. Cool? Cool beans. All right, here we go. Section 5.1, leave your packets on your desk so I can come by and breeze through. If for some reason your packet is not here, be super genuine about it, and maybe I'll let you send me pictures when you get home or something, or have someone bring it so I can see. I think I might have heard something like something got left at home. Ready, set, note, let's go. Ready, set, note, let's go. I'm going to pause the recording because anyone checking this out doesn't necessarily need to sit and watch us take fields. Fields of slopes. If I were you guys, I would bring your calculator maybe for the rest of the week. I don't think you necessarily need it today. It's going to be off and on that we do need it. There are some really cool programs with slope fields. The dilemma is they won't give you these questions on the calculator portion of the test anyway. It might help you. Some of the programs might help you for homework, but if it wouldn't help you for the actual AP, I don't really make a big deal about it anymore. I used to like get out my calculator and then we plug in everyone's calculator and download the program. So there are some cool programs with slope fields. That's also to say, though, I mean, a lot of you guys have more computing power on your phone than your calculator. So that means there are also different things online that can find you slope fields as well. But once again, when slope fields get tricky, there's no way to use your calculator, not really. So we're trying to get the idea of slope fields. There is a homework packet to go along with this. I mentioned yesterday briefly it's going to be due on Monday. You guys should get it tomorrow. I'm getting it copied off today. So there is the homework in the book that's due first, number 33, due on Thursday, but there's also going to be a homework packet. I should have it ready by 0 period tomorrow. Some of you guys might want to start playing with it in 0 period. But what is a slope field? Okay. Has anybody ever played that really old game, Minefield? The really, really old one? Maybe it's not, I don't know, maybe old things are coming back. But if you just even hear Minefield, even if it's not a game, which, I mean, it really wasn't a game for most of history, what are minefields? Oh, Minesweeper. Thank you, thank you, thank you. What are minefields? Sorry. Minesweeper has a minefield in a way, shape, or form. Yeah. Yeah. So I want you guys to think slope fields in the same sense. It's a field filled with, but not mines anymore. And it's not necessarily like one here, one there, one there. There are certain points at which we are going to be doing something. In order to map out mines, well, if someone actually cared about it, it could hurt people later if they didn't find all the mines. There are horrible stories of mines that were left behind in different wars and conflicts, etc. Horrible stories of fields that were not mapped out, and people, just civilians and kids that got hurt, etc. But slope fields. We're going to have a field of, so literally it's like a big old graph, a big old portion of lots of slopes. Lots of slopes. However, do you guys notice that it says line segments? Is that weird in calculus? Have we dealt with any line segments? We've dealt with lines, right? Tangent lines, whoosh, secant lines. Whoosh. Have we dealt with line segments? Why? Okay, imagine a field full of slopes and all of them are infinite lines. It could be a mess, and you guys will see that in a second. So we have to scale back and not look at slopes or tangent lines that go on infinitely, but just little baby segments. The slopes will be determined by a differential equation. Wait, why? Now, we haven't talked a lot about differential equations beyond the fact that Chapter 5 is integration applied mostly with differential equations. But differentials, we know those. Differentials are dy dx, right, guys? Why would slopes be determined by a differential equation? Oh, differential equations are derivatives. Why am I putting f of x? Because we learned with integration, well, this could be your original given, and then you have to integrate to go back. So this could be velocity or acceleration or even position if you're doing like accumulating different distances. But long story short, you could be given the derivative, and if you're given the derivative, guys, doesn't the derivative determine the slopes of tangent lines? Right? And not even necessarily just x, maybe even x and y. So some differential equations, this is going to be weird notation for you. Some differential equations only have x's in them. They're in terms of x. And some of them will also be in terms of y, which means it's more like implicitly stated with x's and y's. So sometimes you only need to plug in x, and sometimes you need to plug in x and y. The purpose of slope fields is to provide a visual perspective of the solutions. Of the solutions to differential equations. Huh? At. Slopes of tangents at xy, at points xy. As we go on, I think I can develop that a little bit more. Let me give you guys one more second. Do I want to add more thing? One more thing? Yeah, let me add one more thing right here. Solutions follow the flow. You're going to hear me say this a lot. Solutions of differential or two differential equations follow the flow in these slope fields. If you guys are remembering the old game Minesweeper, everything was very rectangular. Going over, going up, you have your little squares where the little grid was. Or if you were mapping out mines, you would theoretically cut the field into different squares, different quadrants, and then map out based on certain distances, okay, to go over and up to get to this mine, or to go this and here to get to that mine, et cetera, et cetera. Slope fields aren't quite like that because everything is curved. In calculus, we can deal with curves. We don't have to keep it rectangular. So following the flow isn't going to be quite so rectangular, quite so regimented. Before we get into slope fields, let's just talk first of all about what on earth I mean about a solution to a differential equation. Now, this is a weird differential equation. At least it's way different than anything you've seen. Because all of a sudden, they just give you this random y double prime minus y is equal to 0? What? This sounds like a weird AP question. Y double prime minus y is equal to 0. But they give us some options, so we don't actually have to go from here to an answer. We can actually test A and B and C and figure out if any of them work. This is really similar to AP questions when they give you some sort of condition that has to be true, and then they say Roman numeral 1, Roman numeral 2, Roman numeral 3, and the answer choices are like 1, 1 and 2, 1 and 2 and 3, 2 and 3. None. So fun, right? But if they give you that type of situation, you don't have to start here and solve. Go use your options and say, all right, well, hold on. What are they saying? Can't I find y double prime for each of these? Y prime is equal to cosine. Y double prime is equal to, well, guys, hold on. I know it's been a while. Take derivatives for me. Derivative of sine is cosine. Derivative of cosine is... And then test it and say, okay, does this work? Would negative sine, y double prime, minus sine equal 0? No. Oh, well, then he fails. Does that make sense? It's like a trial and error approach. So you might be like, well, nothing's going to be this. Well, trig, derivatives eventually come back. And if you were to keep going, if it was y quadruple prime, if it was the fourth derivative, it actually would get back to a positive sign minus a sign would equal 0. Who else's derivative could come back to be himself? Exponential functions. So y prime is equal to, keep the c, e to the x. Y double prime is equal to c, e to the x. Guys, aren't all the derivatives of this guy c, e to the x? C is a constant, e to the x, his derivative is himself. So that's one. But remember, AP questions, it could be more than one if it's like a Roman numeral 1, 2, 3 sort of thing. So who's your y prime of this guy? Why did Patricia say negative for? Chain rule, u prime, right? Derivative of e to the u is e to the u times u prime, and the derivative of u, aka u prime, is negative 1. So it's y double prime. For e to the negative x, because it's still e to the u, but you still need another, or you do need another negative. Huh. So B and C, yeah? Just a quick visual to differential equations getting harder. How would we go from there to there? Ooh, we wouldn't. We don't know how. But we can go the other direction and be like, oh, I guess it works. But also notice something else. Differential equations are somehow in terms or including derivatives. And not always what we would call first order derivatives. There's a whole class in college called differential equations, diffie-Qs. Some people call it ODE, ordered differential equations. Usually for engineering, computer science, math. Differential equations, they deal with, well, not just the basic ones we're going to see. There are harder differential equations, first order, second order, third order, that include second derivatives, third derivatives. Kind of like the degree of a polynomial is the order of a differential equation, which derivative you're going up to. It could include seconds and firsts and regular. But differential equations include or involve rates of change, derivatives, and solutions don't. Does that make sense? So somehow derivatives are here and then they're not. So in some way, shape, or form, integration, antiderivatives, if it's possible to be solved, can go from or get you from a differential equation to a solution. But here's the dilemma. Did you guys just hear me say in college there's a whole class about these when they get tricky? Guess what that means about the ability to antiderive? It's not always there. In really complicated situations, you might not be able to antiderive, and so then you have to go to approximation techniques. And one of those approximation techniques, as far as visually seeing the solution, is a slope field. I know I'm building a lot of groundwork, so hang in there. General versus particular solutions, you guys already kind of know the difference to this because you guys know antiderivatives versus the solutions to initial value problems. That's wording from the test you just turned corrections a little bit ago. That was the end of last week, I think. General versus particular. Remember, in general, if you can solve, you might be able to get some sort of antiderivative plus c. Let me use a capital F, just, I don't know. I was using a little f a second ago to be the differential equation. And remember, with general, there are solutions. Now, careful. This right here is a very, 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 very basic formula for a general solution. Meaning, the only difference is vertical translations up or down. There are much more complicated differential equations that we're going to see where the c doesn't end up being added at the end. Legally, because of the math, because of the antideriving, or the antideriving, c ends up multiplied by an e to the x. How does that happen? We'll see it as we make our way through this chapter. But anyway, this is just a basic form of infinitely many solutions. But the nice thing about a particular, remember, is that there's some sort of given of the solution, some sort of established point. And from that established point, it could be initial, it could be when t or x equals 0, but it could not be. It could be at some totally other random place. But as soon as they establish some sort of x, then remember, we can go ahead and plug that in to our general solution. This is the most basic form. And then we could see, right? So general, there's infinitely many. Particular, there's one established. If we're talking about approximating, we might not have the perfect, well, we won't have the perfect equation necessarily. We might not even have the perfect graph, but we're going to have an idea. We might get back to that example tomorrow. I think I want to go here. Let me zoom in on this page and let me finish grading as I have you guys write down the general idea of slope fields. There was another topic, another example before, but we can cover that tomorrow. I want to get you to the idea of what a slope field actually is. We're not making this a forever card. Maybe we should. This is one of those topics where I think, after seeing it a few times, we might make a forever card about certain particular clues, but not the definition. So it's just in a yellow box because I think it's important. But give me some sort of evidence it's done, okay? Before you grade it. Check out the video from yesterday. Maybe I can give you a few hints to that one. And then watch out for that word explain. Try to add a little more detail. Yeah, that video from yesterday might help you a little bit on that one. Let's see if there's a way you can put words to it. Keep working on tonight, right? Okay. You guys see the dy dx in there? You're writing out at every point? Every point. Aren't there infinitely many points in any graph? Assign a small piece of a tangent line, a baby tangent, with a slope found from the differential equation? Now they put f prime of xy. That's kind of like my differential equation. I named him f, they named him f prime. Remember, they can change that up. Just Joyce was absent. The time's getting short. Ideally, what you would want by tomorrow for us to be able to bust this out is not only this page of what a slope field is, but also some hints about how to do it, which we're definitely going to go over. But I just want to kind of show you me doing one real fast. I want to show you me doing one really quickly. Because ultimately, for a slope field, what you need is to basically figure out slopes at all sorts of different points. But you only have to worry about the points that are, okay, there are infinitely many points, but imagine baby tangents at all of them. We wouldn't know what's going on. So instead what we could do is figure out points like -1, -1. I'm starting here in the bottom corner. And then I could either go by row or I could go by column ultimately. So I could do 0, -1. I'm doing that bottom row. I could do 1, -1. And ultimately what we have to do is plug each point in. Sometimes you need the x and y, sometimes just the x. So the nice thing is with this one, if I plug in x is -1, that's a 1. If I plug in x is 0, that's a 0. If I plug in x is 1, that's a 1. What does that mean? When I come down here at the point where I found, I want to make a tangent line. It messes everything up. But if I just up at this point, a little baby tangent line, that one's going to be 0. This one's also up 1 over 1, just approximating, pretending as though I were to connect. Don't even go one whole up 1 over 1. And if you guys notice, those probably should be about the same, right? Oh, I just erased my point. Now, it might be like, well, what does that mean? Well, hold on, though. Do you guys notice that x is what this whole equation is dependent on? So if x is -1, any of those points are going to be the exact same. If x is 0, any of these points will be the exact same. And if x is 1, any of these points are the exact same. Now, this might not mean much to you unless I was to say something like, what if the initial point is 0, 1/2, and then I tell you to follow the flow? Wait a minute. Why does this make sense? What's the solution of an x squared derivative? Some sort of cubic solution for the antiderivative. All right, cool kids, get out of here. I'll see you later. That's the idea of a slope field, though. Putting in some baby tangents and saying, if I follow the flow, what is that? Sometimes it's easy. Sometimes it's a little bit weirder. So it's a kind of cool idea. Bye, guys. No AP forms. Yeah.